Cool. Well, thank you so much for, first of all, being very patient with me and for being here for this presentation that, oops, I have to figure out Mac controls now. It's one of the very first time that I'm going to give this talk. So I'm looking forward to get some feedback and to know how you like this and if it was helpful to you at all or not. Good. So let's start with our presentation, I'm going to talk about Kubernetes. First of all, I'm a bit of a foodie, and I've been wanting to do a talk about like something related to food for a while now. And it's kind of funny because the first time I looked at Kubernetes, when I joined my new job just a few months ago, I was like, bloody hell, this thing is a nightmare. Which kind of reminded me of Gordon Ramsay. So I'm a bit of a foodie, also a fan of the Food Network. So the original title for my talk was Kubernetes Hell's Kitchen in honor of Gordon Ramsay, but I don't have permissions to use the name of his restaurant nor his picture. So I'll stick with stock images of people being very happy, things like that. So all right, Kubernetes is a beast. So when I first had to learn it, I thought it would be easy. I mean, I can pick up new programming languages if I need to, and so on. It's not that complex, but this whole DevOps thingy was like a whole new world to me. It was a very complex beast to tame, but it turns out it's not that complex. I mean, the only thing that Kubernetes does is it'll take care of spinning up and down different containers and managing the networking between them. Essentially, that's all it is. That's all. That's all it does. So it's an orchestration tool that aims at making it easier to manage your containers. So it seems easy now, doesn't it? Well, there are many ways to do those. And one of the things was that I had to struggle a little bit with was understanding the whole vocabulary and all the different things. So I'm going to try to focus on this today. I'm going to show you different components and the different primitives in Kubernetes. And as we progress, I'm going to deploy an application. So I have a full Node.js application that uses a bunch of different microservices, and I'm going to deploy that as we progress. So first of all, what problems does Kubernetes solve for us? Well, first of all, it distributes containers in a logical and efficient way. So it distributes them on different machines. It will take care of balancing the load on your different machines. It helps you to scale up and down really, really fast. So it can very quickly put up some new pods, which we'll see what they are later, but essentially just putting up some new containers. If the load gets too high, it takes care of load balancing, all that stuff. And if the load gets lower, well, it's very easy to scale down. It keeps processes continuously working, so it'll make sure to always monitor all your system. If one of your containers crashes for some reason, it will try to restart it automatically, or just destroy it and start a new one if that's what's needed. And all of this is done with YAML files. So you'll have to do a lot of YAML, but really that's all you have to do for Kubernetes is just setting up your YAML files. Sounds cool, right? So just take my money. Let's it'll solve all of my problems. Let's just go. Well, not quite. I mean, maybe your application is a little bit like this. It does one thing at a time. You don't have millions of users, but you still want to make sure that they're served in a timely fashion. So maybe you joined the Jamstack movement and you have a static website, or you have a WordPress or a Laravel application. Then the food truck model is a little bit better suited for you. So, just having a hosted application on Netlify or GitHub Pages or any other virtual host will probably ensure that your application is stable and you don't have to worry a lot about it. But it's very, very easy to deploy and maintain. So maybe you don't need Kubernetes in this case. Oh, there it is. All right. But maybe you have a pizzeria, maybe you have a small shop with a relatively simple workflow, but you have one person at the cashier and one person in the kitchen. So it's kind of like a startup, you have a front end and a back end and not too many customers, but you need to start with best practices by now. So you'll probably need to use containers to deploy your application, but you can still easily use a service like Heroku to handle this. You can easily just take it down and just put a new container. or integrate that as part of your CI/CD process. But if you start with using containers, it'll definitely make it easier to scale up once you get a little bit bigger. Or maybe you have a buffet. It's like my favorite one these days. You have a serverless infrastructure. So people just take whatever they want. They just leave. They go for another one. So kind of like serverless, there's no real heavy lifting needed, but only a lot of small operations. Then there are ways to do serverless with Kubernetes, but there are a lot of different alternatives that you might want to look into, so Lambda or Azure. But if you have an upscale restaurant, this is different. So you'll need multiple staff members. Each one will have a very specific role. Some people are allowed to speak to each other while others aren't. The processes are a lot more complex, and a single plate might require the input from many cooks. And you can't have a single point of failure. So all of those parts, you need all those parts at any given moment. And this is where Kubernetes will come into play. It will help to ensure that all the people are there at the right place at the right time, and it will help with all those lines of communication. I really like this image because if you look to the left, that's actually me. So I used to be a model for a very fancy restaurant there. So there I am. So, oh, there it is. Okay. So what this Kubernetes does, it'll deploy more or less containers depending on your load. It'll distribute the load across different pods or the different clusters, across the different nodes, and it will take care of all the networking for you. All right, so we're now ready for our grand opening to start our new restaurant. So we're going to open up an upscale restaurant now. But before we do so, let me just quickly introduce myself. So my name is Joel. I work as a developer advocate for Red Hat OpenShift. So OpenShift is a distribution of Kubernetes. By all means, go take a look at it, try.openshift.com. I also help to co-organize Nomad.js, which is a group similar to this one. So we have monthly meetings. And I absolutely love Twitter. So if you ever want to get in touch with me, Twitter is always the best way. Bhaskar knows how to reach me. So he always tags me in posts on Twitter, and I'm always very excited. So if you ever have any questions, feel free to reach out. I'll be more than happy to answer any questions that you might have over there. So my Twitter handle is Joel with 2_Lord. I believe it's down there on the left side. And it's 2 underscores, so that's a little bit tricky, but hey, that's what it is. All right, so let's get ready. Let's open our restaurant. So one thing I didn't mention in my intro is that I'm French Canadian. So that's the charming little accent you might have noticed there. So let's open our restaurant and we will serve poutine because French Canadian. Yeah. But not any poutine. We want to serve upscale poutine, like foie gras poutine, or this amazing duck confit poutine that is served in a restaurant near where I live right now. So the first thing we'll need is an actual place to open this restaurant, right? So we'll need to find a space and make sure that it not only has the actual space, but also all the required facilities. So we'll need to make sure it has electricity and gas for the oven and all that stuff. Maybe even a kitchen. And of course, we don't want to build all of this. We want to be downtown. We can't just tear another building, so we'll just rent out a space, right? So when we rent this space, we'll sign an agreement with the owner, and the owner will guarantee a given set of resources, and it will take care of fixing any issues that we might have in that rented space. So just like when we want to rent out our retail space, we can rent out a Kubernetes cluster. So typically you can run Kubernetes on your own infrastructure, but a lot of major providers will have all of those available for you to use right out of the box. So Azure, Google, DigitalOcean, and of course, Red Hat OpenShift. Standard tools can be used to manage those, but they all have their own tooling available too. So, and we will use nodes. So each one of our Kubernetes cluster will have a bunch of different nodes. It'll always have a master node and multiple worker nodes. In our case, we will only have one node. So I'm running a Minikube on this machine, which is a tool that lets you run small Kubernetes cluster on your laptop. So our restaurant also only has one node. So all of our pods are going to run into this single worker node. So the worker node will host all the different pods, which are all the different components to our application. And then we have a master node, which is the unit that will take care of deciding where all the different pods should live. So it'll take care of dispatching and distributing the different containers in a logical and efficient manner. For now, I'll use containers and pods because they're very similar. But just so you know, a pod can contain multiple containers, but just to understand, it makes it easy to refer to containers for now. So you can have multiple master nodes if you want, but they're usually only there to be there as a failover if one of them would fail. All right, so we can start our cluster. I already started mine just because it takes maybe 1 or 2 minutes to get started. So I'm using Minikube on this laptop. So Minikube is a tool that will create a virtual machine which will have a Kubernetes cluster in it. So you can use it and you can deploy or test and experiment with Kubernetes on your local environment, so on your laptop. So I just use Minikube start. It started. If you want the information to install it, it's actually very painless. I just installed it. Like I said, it's a brand new machine, so I installed it about an hour ago, and it works. Well, let's hope that it works, or else all my demos will fail. So, all right. So now that we have a restaurant, we have our cluster and our different nodes. We'll need some staff. Right? We'll need the different people for our restaurant, and all those people have very specific expertise that we will need to explore. So in here we have our chef, our managers, our maitre d', we have our waiters, our cooks, and so on. And as it gets busy, we'll need to add more people to help out with the load. And they can't work all the time, so we'll also need to replace them from time to time. Without them, So without them, nothing really happens, right? We only have an empty building. So pods in Kubernetes, they're the workers inside our cluster. So they are composed of normally one container that will do a specific job. Sometimes you can have more than one container in a pod, but let's ignore that for now. So they live on the nodes and they can be destroyed at any moment to be replaced by another one. So that's very important. When we talk about containers being ephemeral, pods are very ephemeral too. So you should be able to just destroy them and create another one to replace whichever pod just disappeared or just died for some reason. So in order to find them, we'll be using labels. Labels are the key to finding everything in Kubernetes. So everything will have a bunch of different labels in order to help us to identify those components. So all the Kubernetes objects will have those labels, and most of our staff in the following examples will be represented by pods. All right, so you can so we'll have a bunch of different waiters on the floor. So those are two in the background. So there'll be 2 different pods running, but you can't just let the workers work whenever they want, right? So they'll be a little bit greedy and they'll work too much, or others will only come on Fridays and Saturdays when they can actually make some money. Or if you have 2 of them, the customers will suffer. Or if you have too many, then it will cost you a lot of money. So this will be a job for our maitre d'. Our maitre d' will be in charge of ensuring that everything goes roundly, and she makes the schedules in order to accommodate and to help with that. So our maitre d' is pretty much like our deployment. So a deployment in Kubernetes is an API object that manages a replicated application. So each replica is represented by a pod. So I've just talked about pods earlier. And the pods are distributed among the different nodes of a cluster, right? So our deployments, they will describe the plan and how we want to dispatch and how many pods we want and all that stuff. And it uses replica sets to ensure that the configured number of pods are running in your cluster. Now I've mentioned that everything in Kubernetes will be described by YAML objects, so we will use a YAML to describe our deployment. All of the Kubernetes YAML files always follow the same pattern, so there's always an API version. There's a kind, so what type of object are we describing here? All the metadata, which is typically the name and the labels for our object. And then you have the spec, which is all the different configuration for this specific object. So let's talk about, let's go back to our maitre d', who will be in charge of deploying or dispatching all of our waiters. So we'll go to our deployment. So our deployment will be API version apps/v1, and it will be an object of type deployment. Now we have our metadata, just like I've mentioned. So we have a name. So we'll just call it front deployment. And we'll give it a bunch of labels. So labels can be whatever you want. So I'll give them a label for the app. So all of the different things that I have in this application or in this cluster will all have Kube Kitchen. And then this very specific deployment will be our maitre d', right? So I'll give it a job, a name. And then I have a section front, so everything that is in the front and everything is in the kitchen is in the back. So just so I'm able to find them easily in my cluster. And finally, we have our specs. So the deployment has a very, well, not very complicated, but probably has the most complicated spec of all of our different Kubernetes objects that we'll see today. So the first thing that we'll want to specify is how many replicas we want. How many pods do we want running at any time? So in this case, let's just say one. And then in order for Kubernetes to find how many of those replicas it currently has running, it'll look for one of those selectors. So it'll find all pods that have a matching label to job equals waiter. And each one of those pods will have the following template. And the template is basically how this pod will be constructed. So each one of those templates will have some metadata again. It will have labels, and those will be our waiters. So you can see here how I have job waiter. And we have the spec for our pods. So the spec will be that it runs from a container, and the name of the container is front, and it starts from joelord/kk front, which is the name of my container, which I've deployed on Docker.io just before this talk. They'll also be running on port 80. So I have a server, that very specific one is an Apache server that runs a PHP, and it runs on port 80. So this is my full deployment YAML file. So don't worry, that's the most complex that we'll see today. So there's a lot of stuff in there, but very quickly, it just specifies that we want one replica of this very specific pod that we'll have. And it will have it will be basically a container running joelord/kk front. All right, so let's take a look at this component, this deployment. So what we can do here, we will use kubectl. Kubectl is the CLI tool for Kubernetes. And we can do a get all, kubectl get all. And I think I might have a bunch of stuff running, so let's just stop everything. All right, I'm ruining some bunches here. All right, so we'll just delete everything that was running. I should have taken a second to grab a glass of water while I'm here, but it's almost done. Of course, the second I got away from my keyboard, it finished. All right, let's clear this. Okay, so we're ready to apply our YAML file that we've just built to our Kubernetes clusters. So if I do kubectl get all, I have nothing. Let's ignore this one for now, but running on my cluster. So I can do kubectl apply -f apply, and I will deploy my deployment. Now if you do kubectl, actually let's just change the slide here. We can see what we have right now. So we have an architecture. So I now have my front deployment, which is controlled by my maitre d', and I have 3 different pods running in there. So you can see they're in green there. That's because they are currently running. So if I go back here and I do get all again, all right. So you can see that now I have all my different pods running, and I have my deployment as well as a replica set that ensures that I always have 3 pods. So one fun thing that you can do is kubectl -- is that how we do it? Scale 1. Kubectl, can't remember how to do it. Oh my God. What we can do though is to do front deployment. And we can just manually go in here and change this to, well, it's not cooperating at all. Let's try VI, maybe it'll work better. All right, replicas, oh, why is it? Okay, it's giving me a hard time. Ooh, shouldn't have saved that. So let's just manually go in here, list the pods. All right, so I know I now have all those pods. I can see that I have this one here. So let's just copy this and we can delete that pod, and we'll do a kubectl get all again. Really? Delete pod. Whew, okay. All right, so I've deleted one of our pods. So basically I've terminated one of our waiters. If I do get all, you can see that I still have 3. So it's very, very quick, but this one has been running for 8 seconds. So when I tried to delete one of them, it immediately started a new one. And then when that first one, or when that one was now running, it then terminated the other deployment, the other pods. So we have this architecture now, and if I try to delete some of the waiters or some of the pods, you know, the whole Kubernetes infrastructure will take care of putting some new pods in there. So that's our replica set working. All right. So our merchant now has these 3 waiters on the floor, but right now there's no way to really find them. So you might have noticed that there was kind of an empty box next to the list of pods. So we don't know who's on the floor. We don't know if it's John or Simone, which doesn't really matter, but we kind of need a way to reach them. And this is where services will come into play. So services will act as an abstract way to expose an application running on a set of pods as a network service. So it'll act as a way to find the different pods in your application, and you can communicate directly with the pods if you want. So that's kind of what I was trying to do here while typing. I was trying to get one pod directly, but it's really hard to keep track, right? Because every time we spin up a new pod, it has this random number that is assigned to it, or a random string that is assigned to it. So by using a service, you're always able to find the different pods that are available to you. And what's really nice is that it'll take care of doing all the load balancing for you as well. So you get all of that for free. So when you're using a service with Kubernetes. So our YAML file will be very, very similar to the previous one that we had. So it will have an API version. This will be an object of type service. It'll have some metadata. So we'll specify a few labels. And then we will give it a spec. So we'll say, well, this is a service for all the pods matching this selector. So job waiter. And we will expose, or they are running on port 80. So this is my full service YAML file. So I can go in there and try to deploy that one as well. I'm having a hard time tonight applying that shit. I think that's because I'm hungry, and the more I talk about food, the hungrier I get. All right. So now I've got this service, and if I do kubectl get all again, I can now see that I have a service that is running right here. So I have another thing running. And this will be my way to contact the different waiters. Okay. So we now have our HRD. We know where the waiting staff is. So that's good. That's great. We almost have a restaurant. So, but as a customer, you'll come in, right? And you'll need to talk to your waiter. You won't go in the kitchen by yourself and order some stuff. So your waiter is kind of your door to your system, or your front end will be, basically. And in order to communicate with that front end, what you'll need is an ingress. So an ingress is an API object that manages external access to the service in a cluster, so typically HTTP. Ingress can provide load balancing, SSL termination, and name-based virtual hosting. So the ingress will basically expose your cluster to the outside world. It can support multiple subpaths, so you can have api.myapplication.com or www.myapplication.com and all that stuff. And it will do the routing based on the request. So an ingress, once again, just a Kubernetes object, so it follows the same pattern. So API version, an object of kind ingress, and then you specify with all the metadata that you have. So you give it a name, and then give it some labels. And then you specify the spec. So for the ingress, the spec is relatively simple. So you just specify which service that will be exposed and on which port will we expose that service. So we'll expose our front service, our basically the way to reach our servers, our waiters, and we'll expose that on port 80. So this is our full YAML file. So let's just quickly deploy that one, kubectl apply front ingress. All right. So I now have my ingress created. So now what I can do is do minikube IP. So I have this IP, and I can actually do a curl 192.168.64.2. And you can see that I have something. So now this application, the waiters are now exposed to the rest of the world, and I can actually access them. So this is the current architecture that I have so far. So I have my maitre d, which dispatches all the different orders to the waiters. So it all goes through port 80. Any incoming request hits port 80 and then dispatches to one of our waiters. So this is our current application. It looks a little bit like this. All right, I didn't spend a lot of time making that pretty, but you know, at least it works. So we've got 192.168.64.2 here. And we have our waiter. So the waiter will come to you, introduce himself. Hi, my name is from deployment, blah, 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 blah. So notice that this one is QHWCB. If I reload the frame, this time I'm getting FX2. So because of the load balancing that we have, it'll not always be the same waiter that will answer our request, right? Now from here, we can order drinks, order our main course, but those don't work yet. And well, of course, that's because we don't have our barmans yet. So we have our waiters, but now if we want to order a drink, we'll need to set up a bar, right? So bartenders are notoriously known for not being reliable. Between the drinking and flirting, they can kind of be hard to find on the floor. So we'll need to fire them at some point. So I'll show you that. But we'll send, and in order to help with this, we'll still need a service to help us find them. And we'll also need a way to communicate with them. So this communication is traditionally done by the waiter, so by an internal service. So we're gonna look at this. So this is our deployment for our bartenders. So this bartender is a Node.js application running on port 3000. So you can see at the bottom here that it runs, that our container will be a KK bar here. It will run on port 3000. It'll restart when it fails. And we want 2 of those bartenders running at any given time. We'll also use a node port here. So a node port is a way to expose a service on each one of the node's IP at a static port. So a cluster IP service to which a service to which the node port service route is automatically created. So the node port is part of the service. So it's part of it'll still use the same service that we're creating to reach all of our bartenders, as well as do the whole load balancing. And it works well when there's a single node, but it's not recommended for most production cases. But I kind of still wanted to show it to you just to see how you can use those in a local environment to play with those. If you're in a production environment, you would still use that ingress, but you would use different subdomains or virtual hosts inside your ingress, which is a little bit more complex to set up. And different providers will have different ways to create routes. So that depends. You kind of have to, in order to expose different node ports, you might have to look into the documentation. So for Azure, you'll need to open up some ports on your firewalls and do that type of setup. All right, so now I have my service that will help us to find all the different barmans that we have. And the service will be of type node port, which is exactly what we've talked about. And it will map the port 3000 on inside our container to the port 31,300 on our cluster. So now we can go back here. We can do kubectl apply, and we'll apply our bar deployment. And we'll also apply bar service. There we go. Come on, really? There it is. All right, so now we can do kubectl get all again. And we see there's more and more stuff coming in, but you can now see that there's 2 different pods that just appeared here, which are our bar pods, so our bartenders, basically. If you want to get access to only those, we can do kubectl get pods, and we can specify a label and job barman. There it is. So we can get only our pods for the specific label. So I was able to do that. So now I also have my service, and you can see my service bar right here. It's a type node port, and we can see on which port it's running. So I'll be able to get access to that one. So now this is what my architecture looks like. I have my different ingresses. I've got my node port, which will expose, so my waiters will now be able to talk to my bar. Now I'll open up a terminal window here. Let me see if I can, I'll just use it in here. I'll hide it for now, but I'll try to get one of the bar pods. So we'll get that first one here. I know I can't see what I'm doing, but what I'm doing is that I'll use kubectl and I'll do delete pod, and I'll use HGTQ9, so the first one. So as soon as I hit delete, you see that Kubernetes started a new server, so it's blue, the ZRDSB. So it's trying to start a new pod, and as soon as this one will be ready, it will actually delete the other one. So this is kind of the beauty of our deployment and our replica set, and it just ensures that there's always 3 of those pods running. It'll take just a second, and we should see that first one on top just disappear. All right, so it's blue because it's currently taking it down, and it's gone. So we're back to our two pods that we wanted. Okay, so I have my application, and I can now order my drinks. So that's good. So we've got our waiter, NLN, and I can now order drinks. Just turn out that it's always the same bartender, but in theory, the drinks could be served by any of them. Okay, so it's now time to go to our kitchen where the real work happens, right? So a lot of people tend to think that there's a chef preparing all the food behind there, but that's not entirely true. In a lot of nice and larger restaurants, there's a whole bunch of people doing a whole bunch of things. Each one has designated stations, and they follow the orders of the chef. So those cooks are replaceable, and they'll even change place during the course of a shift, but the chef will always know where they are. But as far as our cook are concerned, we have a deployment once again. So we'll have a bunch of different containers running KK Cook in this case. They're all a Node.js application, so very similar to the one for our bartender. And each one of those cooks will be able to serve different components of our meal, depending on what they've been asked. So I'll run 2 different replicas of our cooks here, and the same as we did for our bartenders, we will have a service. But this will be a service, and it won't be exposed. So this is not a node port, so there's no way for anything else or anyone else to actually access those. So let's just go in here and deploy those 2. Kitchen cook deployment. Okay. What? Wait. Yeah. Apply. That's what I was missing. Service. There we go. All right, so we now have our deployment and service exposed. So this is our current app architecture by now. So as you can see, we've got a lot of stuff going on now. So we've got our front-end application. We've got one API that will serve us drinks. We've got another service that will serve us some food. But this service, I did mention that there's no port exposed. So there's no way for now to actually contact this cook. So there's no way for the customer to just get up and go into the kitchen and ask directly to the cooks what they want to eat, right? And that's something that we don't want in a restaurant, or else that would be just a nightmare. So that brings us to our chef. So the chef will normally be the one, there's only one, and he will be in charge of dispatching the orders to the different cooks, and then take all the elements and do the final little assembly, or final little touch, and give the final approval to the plate so that it can be served back to the waiters. The chef is also the gatekeeper to the kitchen, so the customers or the waiters, they can't just start talking to the cooks. You have to go through the chef, or else it'll just be a nightmare. So the chef will be there to communicate with the cooks, and as well as with the waiters. So our deployment is very similar. Just notice here that I have both a deployment and a service inside the same file. So you can have more than one. So far, I've used different files, but you can use a single file to do all of your different objects as long as you separate them by those 3 dashes here. So I have my Chef Node.js application, once again, running on port 3000. It is deployed on Docker Hub with this container name. And I'll have a service, and this service will use a node port, just like we did for our bartenders. So the chef will be able to reach him on port 32,300. All right, so let's deploy our chef now. So kubectl, let's see if I can actually get it right on the first try this time. Kitchen, chef, and multi.yaml. So there you have it. So I've just deployed or just created both my deployment and the service both at once because they were all in a single file. And they're very, very similar to the bar. So I didn't spend a lot of time there. So now this is what we have. So we have our maitre d', our waiters talking to which we can talk. We have our bars, and we will have a way for our waiters to talk to the chef, like through the pass here on port 32,300. And the chef will be able to internally talk to our different cooks and ask for the specific elements that he needs for the plates. So now we can order our drinks, we can order our main course. And as you can see, the chef requested for some fries. So the cook MPKFQ served some French fries. And then the chef asked for some cheese, and PJS66 served some fresh cheese curds, and so on. You have a demi-basse au bois, some duck confit. And the chef finally assembled everything and served us this very nice JSON file. So you can see that the different elements have been prepared by different cooks. That's because we have some load balancing going on. So when the request was done to the service for our cooks, I'm sorry, I'm about to sneeze. I think it's under control now. All right. So when the chef did the request to the different cooks, it was low balance, and different cooks will serve the different parts. So if I try it again, you'll see that it's never the same. So it's just all the load balancing is done by the service. Now, there's one thing that I did mention is that there is no way really for the waiters to communicate with the chef. So how did the chef communicate with the different cooks? Well, we can find the address of different services using the internal DNS. So there's an internal DNS inside inside of our Kubernetes cluster that we can use. And there's a different environment variables that are available for each one of your pods. So we could see here that we have a host, and the cook service host was stored in one of the global variables here. So by using those environment variables as well as the different, as well as the internal DNS, you're able to build those URLs that only are accessible within your Kubernetes cluster. So that way, my chef was able to talk with the different cooks, and anyone or nobody from the outside of the Kubernetes cluster was actually able to talk to those cooks. So that's very important. So you can kind of hide your services behind that, and nobody will be able to talk with them. So there you have it. We've got like quite a lot of things that were installed so far. So we've got this whole architecture with a bunch of different microservices, some of whom only talk internally, and so on. But there's a big problem that you might have noticed so far. So all of those are running basically containers. And I've mentioned many times, it's very easy to scale up and down. You can basically kill them and bring them up and so on. That's very easy, that's great. But what happens if you want to keep some data somewhere? So this is where we will have our pastry chef come in. So and our pastry chef is a little bit different. It doesn't really act like a server. It doesn't wait for somebody to ask for some truffles or to ask for a creme brulee. It'll actually prepare all of that during the day. So it'll take a lot of, during the day, the pastry chef will prepare all this stuff for you. And it will need to store all of that into some place where the chef will be able to access it afterwards. So our pastry chef is a cron job, basically. So containers are not necessarily a server. It could be a CLI, it could be a daemon, or in this case, it could be a cron job. So to deploy a cron job on Kubernetes, you'll use same type of thing, API version, the kind of type cron job. We'll have our metadata, so we'll specify the name of it, the different labels for it. And we'll have a spec for our cron job. So it uses schedule, very similar to Unix-based cron jobs. So this one will run once every minute. And every minute it will run a container that is called KK-pastry. So the restart policy will be on failure. So if something happens, it will try to restart it. Sorry about that. So this is my full deployment. So once they're done, creating those nice desserts for us, they'll then need to store it somewhere. So they will store it in a fridge, and this is where the chef will be able to get them and bring those final touches and then serve it back to our waiters. And to do that, we will use persistent volume claims. So after a pod is terminated, everything is destroyed, which is great. So you can spin them up and down as much as you want, but you still need a way to persist some data and to be able to share it between the different components in your system. So you can claim some space made available to you by your admin. So your admin will put some what they call persistent volumes that you can then use. And you can take one of those persistent volumes by using a persistent volume claims. So persistent volume, they are typically set up by your admin. They'll have a bunch of different properties. It'll specify if they're read, write, read only, where they are mounted on your machine, and so on. And you have some storage capacity. The claims, on the other hand, will kind of be a way to claim one of those persistent volumes. And you'll say, well, you'll need to specify the storage class name. This one is a little bit tricky. All of the persistent volume claims are actually a little bit different on each one of the providers that you're going to use. So Azure has different class names than DigitalOcean has, for example, but they're kind of all very similar in the way that they work. So in this case, I want one persistent volume that has read-write many, which means that many pods will be able to read and write to it. And I need at least 1 GB of storage. So Kubernetes will pick one of those 2 GB persistent volume that I have and give it to me because it is at least 1 GB. And once I have this persistent volume, I can mount that volume into one of my containers. So my pastry chef here will have a, I'll mount that volume as my pastry fridge. I'll call it the fridge PVC. And then my chef will be able to volume or mount this volume. It'll mount it to the path/desserts, and it will use the pastry fridge volume, which was defined right here. So you can, well, now that you have those persistent volume defined inside your Kubernetes application, you can use them and mount them so that some of your containers will now be able to use them. So let's deploy all of that now. All right, apply. Start by the fridge. So we have our PVs that we need to define. Like I said, those are typically defined by our admin. There's one already defined. We'll define our persistent volume claim, so it'll take the first PV that is available. We'll also deploy our pastry chef. So the cron job, which we've seen already, so that will take care of starting a cron job every minute, and the cron job will basically just store a file on that persistent volume claim, and each one of the files represent a dessert. And finally, we'll need to change our chef definition so that it actually takes into account that new volume that we've just mounted. So we'll use kubectl apply chef kitchen chef, and I had this one, which includes the fridge definition as well. So you'll see that when I deployed that one, it's exactly the same, but there's now this volume mount part. And you can see that the deployment was configured and the service remained unchanged. So really look for the same service, saw that there was no changes there, but there was a change in the deployment. So it released or redeployed that new deployment configuration. So now we have our full application. Let's cross our fingers. So we come in, our front deployment comes in and asks us what we want, so we can order a drink. And I'm just about due for a beer right now this time, but and then we can order our main course. So this main course, we have some fries, some fresh cheese curds. We had a demi-glace au poivre, and we have some duck confit, which was prepared by all of our cooks. and then assembled by our final chef. And then we can order some dessert. And you can see that I have a dessert which was prepared at midnight 24 local time on my cluster, or UTM. And we have no more desserts left, unfortunately. If I try to order another one, there it goes. I don't have any one. So there's one per minute that is being prepared. So I don't have any dessert now. If I take a sip of water and I just wait a few seconds, maybe we'll have another one. A minute is a long wait when you're speaking and you're just alone in front of the laptop. So I'll just, oh, there it is. Okay, so we've got another one which was prepared at midnight 25. So every minute we have a new dessert that is being prepared, and the chef can pick from that pool. So basically it'll just delete that file once it takes it. Final look at our architecture, which is getting more and more complex. So we've got our waiters. So we've got 3 pods running, 3 containers running Apache, and pre-configured with PHP, which all listen on, which are all served by a load balancer, which is our ingress here, our maitre d here, and they are serving on port 80. Then that front end will need a way to talk using an external port to our bar and to our chef, because we're using Ajax request here. So we have this, this service bar exposed to port 31300, and we've got 2 barmans which will serve the different drinks. And now we've got our pass where we can speak to our chef, which is on port 32300. We've got a single chef, and that chef can internally speak to all of our different cooks. We only have 2 working right now, but no external application, so no customer can ever come and talk to those cooks. And finally, the chef can also pick from the fridge, and we've got our pastry chef just producing desserts, so putting more files into this volume here, and our chef can take some of those files and delete them as long as there are some desserts left. All right, so just a quick recap. We've got a cluster, which was a set of machines, so a set of different nodes. We had a master node, which was managing all the different worker nodes, so it was dispatching the pods on those different worker nodes. We only had one in this very specific example, one worker node, which would contain all the different pods that we had. Our pods are our basic Kubernetes unit, so they're the little unit of work that we can have. Typically, it's one or some very, very related containers running inside a pod, but typically just a single pod or just a single container. We've seen what are deployments, and so deployments are basically your schedule for a different pod. So you specify how many you want, and there's a lot of configuration that you can do there, but typically they would just define the replica set and specify how many pods that you want there. We had services that we've used. So services took care of doing all the load balancing and accessing all the different pods. So it didn't matter what the name of the pods were. So because we didn't have to access them directly, we had our service to basically dispatch the work to all of our different pods. The ingress, very, very important piece. The ingress is very different from one host or provider to the other. So that's one thing that you might still have to do a little bit of research with. But the ingress will expose the service to the external world. So this is why I was able to access my application on port 80. And then we have the different ports, which will open directly a port on a single node. So it works when you have a single worker node, but if you had multiple nodes, then that could be an issue there. We saw cron jobs as well, which run jobs at a regular interval. Finally, in order to persist data, so if you have a database, for example, you'll need persistent volume, which were defined by the admins, and your persistent volume claims, which is a mountable disk that is used by your applications. So I've used kubectl apply f with the YAML file. So this is pretty much how you'll deploy different files. You can use get and get the list of pods, for example, by using kubectl get. Kubectl get all, which you've seen me use. You can also specify different labels, so you can get all the pods of type job equals barman, for example. Then this kubectl describe. And there's a few different things that could be interesting as well to use. kubectl logs works a little bit like Docker logs, which lets you see the logs of a specific pod. Very helpful if you have a pod that is crashing or something that's going on and you don't know how to, or you can't figure out what's going on exactly. So kubectl logs can be used there. And you can also use kubectl exec exactly the same way as you would with a Docker container, for example, in order to just log into that pod and see what's going on. So you can actually log into a container and see different things. So from there, you can also see the internal DNS and kind of start pinging the different services. So that can be very useful if you're stuck at some point with Kubernetes as well. All right, so I'll skip the more Kubernetes. I think we've all had more than enough by now. So obviously this was kind of an oversimplification of a very, very complex thing. I mean, running a restaurant is much more complex than that. And I haven't talked about all the different roles in the kitchen, like a grill master or garde manger, and I've left out like a bunch of different roles in the dining room. I mean, not all wares are equal, and of course some important things like the sommelier, you know, which is very important, but has been left aside for the sake of simplicity. But we're not here to talk about restaurants, of course. But in the same way, we can't really describe all of Kubernetes in an hour. But it should give you at least the basic building blocks and the basic foundation to help you get started. So now that you have those, you know how to run Minikube, and you kind of know a little bit about containers. You're able to figure out, okay, well, I need a deployment and I need a service to find my different pods. So go ahead, try a little bit, explore different things to you, and from now, hopefully, you have enough information to be able to start, just Googling for questions. So I'll leave you with more resources. Kubernetes, the official doc, is great to explain all the different APIs. There's a great Google Docs, Google Cloud Kubernetes comic, which kind of describes all of those in a very fun and comic strip. And Fippy and Friends is a great book to explain Kubernetes, to a 5-year-old pretty much. It's a nice illustrated kid's guide to Kubernetes. So it's definitely worth taking a look at that one. I have a printed copy here somewhere because I couldn't resist buying one. So that's all I had for you today. So thank you so much for being here. And if you want more information, easy URL to Kube Kitchen or reach out on Twitter. I'm always available. That's Joel with 2 underscores Lord. Thank you.
Thank you, Joel. Thank you for explaining us Kubernetes in a good way, in such a way that even a beginner can understand it very easily. As you told, I'm going to buy the book which you told me now, because Kubernetes is such a complex topic, and if someone is able to explain it to a 5-year-old very easily, then that's a book I'm going to read as well. Okay, so do we have any questions?
Yeah, great presentation. Thank you so much. I always find that one of the, as a developer, one of the things that always stumps me when I'm trying to do stuff with Kubernetes is just the amounts and pages of YAML that you have to write. Have you found any sort of like developer friendly way to just like have like templates that you fill in or something like that, I mean, I recognize that once you have it, you have artifacts that you want, likely will have checked into source control or something like that, but just getting started, kind of the blank page problem.
Mm-hmm. Yeah, I found a few tools. So I'm also very new to Kubernetes. And as I mentioned, I joined Red Hat OpenShift just a few months ago, and I didn't know anything about it when I joined. So I had to dig a little bit. OpenShift in itself is a product that aims at making all of that easier. Right. So there's a nice web UI that you can just poke and it'll take care of deploying all this stuff for you. And you can still take a look at the YAML files, and that helps to kind of see, oh, this is how I will deploy an application, or, it kind of gives you a few of the basic building blocks. So that definitely helps. One other great tool that I found, which is unfortunately not supported anymore, but it's still helpful to, just like you said, to get over that blank page. But if you use Docker Compose a little bit, which is kind of a, well, definitely easier way to start putting all of your containers working together in your local environment. And once you're done and you have something that is working on your local environment, you can use kcompose. So that's KOMPOSE. And it'll generate all of those Kubernetes YAML files for your Docker Compose setup. So it's meant for simpler setups, but it's definitely a great way to get started. If you have two or three containers running on your machine, all with Docker Compose, and you kind of want to see what would be the equivalent on Kubernetes, that's definitely a great tool to give you that basic YAML files.
Right. Awesome. Cool. Thanks.
So I don't have any questions in Twitch, but there was a feedback that the session was wonderful.
Good.
So thanks for giving this talk, Joel.
Well, thank you so much for having me. It was a pleasure to be here.
So, and one question I have related to Docker, but not about Kubernetes, because recently there was an announcement that Red Hat is going to remove support for Docker. So, do you have any insights on that?
I am not sure. I don't know. I really don't.
Yeah.
So what I know for sure is that Red Hat has been working on their own version, and it's not really their own version because there's an open standard for containers, right? So any tool could potentially run containers, and Red Hat has been working on Podman, which is an alternative to Docker. And Podman works in exactly the same way. For the longest time, I was, well, up until just an hour or 2 hours now, I was running a laptop with Linux instead of this MacBook. And Podman runs only on Linux. And one of the big advantages of Podman, as opposed to Docker, is that it runs, it doesn't run with a daemon. So the way Docker works is that it has one daemon that will take care of running all of your different containers. And I'm kind of simplifying that a little bit, but so you've got that one single point of failure, which could potentially fail, and all of your containers will crash. So that's kind of an issue, and Podman runs without that single point of failure. So it runs all the different containers directly in Linux without that single daemon there. So if one crashes, it doesn't take all the others down as well. So I think what you might have heard or might have seen is that they will support Podman in favor of, or they will drop support of Docker in favor of using Podman instead as an alternative to, but it's not that it won't support it or it won't work anymore. It's just that the way to go will now be with using Podman.
Yeah. Thanks, Joel.
Well, thank you so much. Have a great day.
Thanks, everyone. Thanks for joining this talk today.
I found that the only downside of doing an online webinar is I can't get any more of your stickers. I caught you last year when you were in Minneapolis for Open Source North, and I enjoyed that talk too. But anyway, thanks again.
That's great. Well, thank you so much.
Thank you, Pete. Yep.
Yep.
Thank you all.